Yes, hello everyone. Welcome to this session on entropy numericals. Here we will solve assignment number 3. So I hope in previous lecture we have discussed the different formulas for the calculation of entropy changes in different thermodynamic processes. So in previous lecture we have learned that there are total type 1, type 2, type 3, type 4 kind of problems in this entropy calculation. Type 1 was for universe, type 1 for universe where uh, it will be adiabatic, and we will get ds universe equals to s generation, and this s generation will be equals to ds of system plus ds of surrounding. Okay, so this was type 1. In type 2 we have one metallic bar which was submerged inside of water, and what was happening there, the metallic bar temperature was very high. Let's it be T1, and its mass was m1, its heat capacity was c1, and water is having mass m2, heat capacity c2, and its initial temperature is t2, and both of these system and surrounding is getting at thermodynamic equilibrium at the temperature T final, Tf. So by energy balance equation, that is from heat transfer by the metallic bar is equals to heat transfer to the heat gain. Heat lost by the metallic bar will be equals to heat gain by the water. So just apply this relation, and we calculated the change in entropy for metal block and change in entropy for water. In type 3 we have used that TDS equals to du plus PdV and TDS equals to dH minus VdP, these thermodynamic relation for calculating the change in entropy for an ideal gas. So this was type 3, and in type 4 we have calculated the change in entropy in open system. Okay, so let's try to move ahead. Let's try to see what are the questions are present in your assignment number 3. ये कहाँ से आ गया? ओके सॉरी यार, ये थोड़ा सा ये बन गया है इसमें. ओके, लेट्स ट्राई टू सॉल्व क्वेश्चन नंबर 1. Question number 1. Figure below shows a system. So actually this is I think from second law of thermodynamics, but let's try to solve this. Figure below shows a system undergo a reversible cycle during which it exchange heat with 3 thermal reservoir and develop 1000 kilojoule of work. Okay, so these setups are given, and it is asking which of the following statement is are correct. Okay, okay, fine. So whenever we will get these 3 kind of thermal reservoir which is acting as a heat engine, so first concept what we have discussed, that first write the so this is QA, QB, QC we have taken here. So first write the energy balance equation, and taking this as a system, taking this heat engine as a system. So what we will get, we will get 5000. This is what in 5000 equals to 1000 plus QC plus QB. This is equation number 1. It is energy balance equation. Okay, and if you see, it is given the cycle is reversible in nature. So we know from classes inequality That is, for a reversible cycle, del q upon t is equals to 0. Del q upon t is equals to 0. Okay, so what we will write? So see, so we will write, so if I take this as a qa, so we will write here qa upon ta, qa upon ta minus qb, qb upon tb. So you can see this qa heat is coming to this, so we are taking this as a positive, and this qb heat is going from this system, we are taking it as negative, and qc upon tc equals to 0. Okay, so we have given the value of qa as 5000, value of ta as 3, ta is 1000, so just write the values here, minus qb upon tb is how much here? tb is 300. Okay, minus qc and tc is how much? It is 500. We will get 0. So from here we will get qb upon 300 plus qc upon 500 equals to 5. Okay, so we will get equation number 2. Now just solve these two equations. Solve these two, equation number 1 and equation number 2. We will get qb equals to minus 2250 kilojoule and qc equals to 6250 kilojoule. Okay, so you can see. Now let's try to see what are the answers. The heat transfer to the reservoir B is 2250. The heat transfer to the reservoir B is 2250. Okay, fine. So here if you see the qb, which we have assumed that qb direction is this side. Now what we are getting this a negative, so what will be happening here? qb direction will be like this. Its direction will be, heat will be extracting from this 300 Kelvin reservoir. Okay, now let's see, the heat transfer to the reservoir B is no, it is not. Reservoir B is 2250. No, this is not. The heat transfer to the reservoir C is 6250. Yes, 6250, this is correct. Heat transfer to the reservoir, that we are transferring heat to this is correct. Heat transfer from the reservoir B is 2250. This is correct. Okay, so this is from the reservoir B. Okay, qb is 2250. This is correct. Heat transfer from the reservoir C is 6250. So this is wrong. So answer will be what here? B and C. Okay, so this is question number 1. Now let's move to another question. Okay, so in this question number 2, which of the following statements are correct about a heat source of 1000 Kelvin is losing heat to a sink of, in one case we have 500 Kelvin, so this is how much, 2500 kilojoule is, that is we have two cases, one is 500 Kelvin and one is this is losing heat at 800 Kelvin. Okay, so this is how much heat, 2550 kilojoule. Okay, now heat transfer in both sinks is reversible. Okay, fine. So let's try to recall now what is happening here. Here this amount of heat is transferred from 1000 Kelvin and it is transferred to this 500 Kelvin. So here we have, in first case I am taking this as a case A and I am considering this as a case B. Okay, now if I take this as a universe, what is going to happen? If I take this as a universe, so this will be our system and this will be our surrounding, this will be our system and this will be our surrounding. Okay, so now let's write for case A. For case A, we know that, so this will be what, type 1. We know that S generation ds universe is equal to S generation. This is equal to what, change in entropy of system plus change in entropy of surrounding. Okay, so what is going to happen? So here this system is losing heat of 2500 upon temperature. This negative sign shows that this temperature, the heat is coming from this, and we will take the increase in entropy for this lower cooler thermal reservoir. This will be 2500 upon 500. Okay, so if we will do this calculation, what we will get minus 2.5 plus 5 equals to how much here, 2.5. okay, now let's take case B. And if I calculate delta S universe or S generation in case B, this is for A, this is for B, so similar we will write delta S for system, change in entropy of surrounding. Okay, तो यहाँ पे क्या होगा, so this will be minus 2500 upon 1000 plus this will be 2500 upon 800. okay, so this will be how much, this will be minus 2.5 and this will be 3.125. it will be equals to 0.625. okay, and unit ध्यान में रखना यार, this is kilojoule per Kelvin, this is kilojoule per Kelvin. okay, now you can see the entropy generation in B is less than entropy generation in A. okay, so what is the conclusion? That S generation in A is greater than S generation in B. What does this means? What does this means? That A is more irreversible than B. Okay, now tell me, if S generation की वैल्यू ज़ीरो आती तो क्या कहते हैं हम इसको? If S generation is 0, then it means that the cycle is reversible in nature. Okay, so the S generation A is higher than S generation B. A is more reversible, more irreversible. Okay, now let's try to check what is the answer. Heat transfer to both sink is reversible. नो, रिवर्सिबल नहीं होगा क्योंकि इसका एस जनरेशन की वैल्यू एग्जिस्ट कर रही है. हीट ट्रांसफर टू बोथ सिंक इज़ रिवर्सिबल. यस, हीट ट्रांसफर टू सिंक 1 इज़ मोर इरिवर्सिबल. Heat transfer to sink 1 is more irreversible. Yes, heat transfer to sink 2 is more irreversible than sink 1. नहीं, ऐसा कुछ नहीं है. राइट, पहले वाले का ज़्यादा होगा. ओके, आई होप यहाँ तक क्लियर है. सो लेट्स गो टू क्वेश्चन नंबर 3. Question number 3. An iron cube at temperature of 400 degrees Celsius is dropped into an insulated bath. So here we have a bath full of water, and it is having one iron block, one iron cube. So let's make it cube. This is iron cube, and this is submerged inside the water. The iron cube. Okay, now let's see. This is water, cool water. Okay. This iron cube is very hot and its temperature is, now let's take one corresponding to iron cube and 2 corresponding to water. Now its temperature is T1 is how much? 400 degrees Celsius. So just add 273 here. It will be 673 Kelvin. Is dropped into an insulated bath containing 10 kg of water. So this is what M2 is 10 kg at 25 degrees Celsius. T2 is 25 degrees Celsius. 273 तुरंत ऐड करें इसमें. So we will get 298 Kelvin. Okay, the water finally reaches a temperature of 50 degrees Celsius. So it is showing T final is 50 degrees Celsius. So this is, I think we have discussed in our entropy formula lecture. This is type 2. Okay, here the cube is submerged inside the water, and cube will release heat and its temperature will also changes. Okay, so that's why this is what type 2. T final is 50 degrees Celsius in steady state if the specific heat of water is 4186 joule per kg Kelvin. Okay, so it is given, C2 value is given. Then it is asking what is entropy change of the cube, what is entropy change of water. Okay, these things are given. Now let's see. Now let's try to solve the question. So first thing which we know, that here first equation which we write that heat lost by, that the energy conservation equation, heat lost by Rn cube will be equals to heat gain by water, right? So this will be what? M1C1 T1 minus T final equals to M2C2 T final minus T2. Okay, now just put all the values here. We will get M1C1 T1 is how much? T1 is 673. TF is how much? This is T1. Okay, so what we have to do, so इसमें TF is 50 degree Celsius, right? But यहाँ पे जब रखेंगे convert, add 273 and add it because this is in Kelvin, right? So this will be 323. Okay, this will be equals to 10 into 4 point, sorry, this is in 4186. C2 is given 4186 into TF, T final 323 minus 298, right? So from here we will get M1C1 equals to 2990 kilojoule. This will be in joule. Why? This will be in joule. Why? Because the unit of C2 is here in joule. This will be joule per kg into Kelvin. This is one relation. Okay, so in this type 2 we have only two equation. One is energy balance equation and one is what? One is that simple TDS equation, okay, for entropy change calculation. And we know that TDS equals to du plus pdv. In case of solid and liquid, del v is 0, and we can write du as mc dt, and cv is nearly c in case of solid and liquid. Fine. So we will get here change in entropy for 1, it will be what? How much? mc dt upon t. Temperature will go from T1 to TF. Okay, this will be for 1. Okay, this is for what? Iron. So this will be M1 C1 into ln TF upon T1, right? So M1 C1 already we get from here. Just you have to put all the values. So we will get 2990 into ln TF is how much? TF is 323 upon 298. Sorry, 323. 298 is for water. 323 upon 673. This is for iron. Okay, so here we will get, just do this calculation in your calculator, put this value, multiply by this, and use ln symbol, and you will get numerator by denominator form. Just enter the values and just get the final answer. You will get minus 2.2 kilojoule per Kelvin. You will get this minus 2.2 kilojoule. Units will be kilojoule. I think what you will get in joule, just divided by 1000, you will get in kilojoule per Kelvin. Okay, now you can see here that the entropy of metal is decreasing because its temperature is decreasing, so we are getting negative value. Okay, now let's calculate entropy change for water. This will be how much? It will be m2 c2 ln tf upon t2. Just do the similar integration as we have done here, you will get the same result. Now do we have the values of m2 and c2? Yes, it is 10 into 4186 into ln t final is how much? 323 upon 298. So we will get how much? 3.4 kilojoule per Kelvin. Okay, so units ध्यान में रखना है. Here we have multiply with 10, here we have multiply by m, that's why per kg वाला cancel हो जाएगा यहाँ से, right? We will get in kilojoule per Kelvin. Okay, now let's see what will be the total entropy change and or S generation. S generation will be what here? It will be summation of ds1 plus ds2, right? Now do this calculation. We will get, just I am writing here, we will get minus 2.2 plus 3.4, and finally we will get 2, 3 में से 2 गए 1, 1.2 kilojoule per Kelvin. Okay, so these are the final answer. Now you can see S generation is positive, then the cycle, then this process is irreversible in nature. Now let's see what are the answers. Entropy change of the cube is minus 2.2. Yes, entropy change of the cube is minus 2.2. This is correct. Entropy change of the water bath is 3.3. Okay, so we got around 3.4. So this is similar, this is correct. Since S generation is equals to 0, the process is reversible. No, S generation we obtain 1.2, which is greater than 0, so this process is reversible. So this is correct. So we will get this A, B and D. These will be the final answers. Now let's try to solve next question. Air is flowing steady in an isolated plate. Okay, so here is air is flowing in an isolated plate. So this is isolated. What do you understand by isolated? Means del Q is 0 and air is flowing from this side. Okay, the pressure and temperature at two sections 1 and 2. So this is region 1, this is region 2, is given in the table. Establish the direction of flow of air in pipe, treating air as an ideal gas, right? So it is what we have to calculate, the direction of flow. We have to calculate direction of flow, and it is given that it is ideal gas. So direction of flow, how we will calculate? So first we have to calculate the S generation value. S generation value. If S generation is 0, the process will be reversible. If S generation is greater than 0, the process will be feasible, it will be irreversible in nature. And if S generation or change in entropy or of universe will be less than 0, then the process is not feasible in the particular direction, right? So our aim is to calculate the change in entropy of the universe. So we know that ds universe is what? ds system plus ds surrounding, and this was equals to del q upon t plus s generation. अच्छा, इस केस में दिस del q is 0, so what will be happen यार, ये टर्म 0 हो जाएगा. ओके, सो दिस एक्सटर्नल irreversibilities ये भी 0 हो जाएंगी, right? So what we will get here, we will get only change in entropy of the system, change in entropy of the system, and system is what? The change in entropy of air. This will be equals to S generation, right? So this, we have this relation, change in entropy of air, right? So let's see, अपन को क्या दिया है? प्रेशर दिया है, टेम्परेचर दिया है, राइट? सो इन कीप इन योर माइंड अपने पास क्या क्या रिलेशन थे. टी डी एस इक्वल्स टू डी यू प्लस पी डी वी and TDS equals to DH. Here H will be capital यार, DH minus VDP. अच्छा, अपन कौन सा इक्वेशन यहाँ पे लगाएंगे? देखो, मुझे P1 और P2 दिया है, राइट? तो क्या मैं ये रिलेशन लगाऊंगा क्या? इसको लगाने से क्या होगा, ये T नीचे आएगा और इंटीग्रेट होके V1 V2 आएगा, तो ये इक्वेशन मैं नहीं लगाऊंगा. ओके, सो विच विल बी वैलिड यार, ये लगाएंगे, DP लगाएंगे तो वहाँ से P1/P2 वी विल गेट. So we will use this equation, this relation TDS equals to DH minus VDP. So just write it. We will get TDS equals to DH minus VDP. So just write this, TDS equals to DH minus VDP. So DH we can write m Cp dt minus v, okay, from PV equals to mRT we will get, okay, this will be what? VDP, right? Now what you do, divide it by T, so we will get like this. So V by T will be what? V by T will be what? MR by P. So this will be mCp dt by T minus MR by P into dP. Now just integrate this. So this will be what? ds integrated from S1 to S2. Okay, S1 to S2, and we will get integrate it from T1 to T2, from P1 to P2. Okay, now we will get m Cp ln T2 by T1 minus m R into ln P2 by P1. okay, so यहाँ पे यार ये चीज़ ध्यान रखना है दैट फॉर आर की वैल्यू अपन लेते हैं, वी टेक आर एयर एज 0.287 किलोजूल पर kg केल्विन. ओके, सो हियर होल थिंग विल बी पर यूनिट kg, पर यूनिट मास, राइट? सो m वैल्यू विल बी, m की वैल्यू कितनी हो जाएगी यार, यहाँ पे m की वैल्यू 1 हो जाएगी. वी विल टेक, बिकॉज हियर एवरीथिंग विल बी इन पर यूनिट मास, So just divide it by mass. We will get what? Change in entropy per unit mass. Okay, so we will get S2 minus S1 इज इक्वल्स टू Cp की वैल्यू, ये चीज़ आपको ये दो वैल्यू थोड़ा ध्यान रखना पड़ेगा, 1.005, 1.005, दिस इज़ ऑल्सो इन किलो जूल पर के जी, mCp, so that Q equals to mCp dt किलो जूल kg Kelvin. Okay, so this will be 1.005 into ln T2 कितना है यार, T2 is 1300, 273 plus 13 divided by T1 is how much, 50 plus 273. Okay, this will be R की वैल्यू कितनी होगी, 0.0287 into ln P2 is how much, P2 is 100 kPa upon P1 is how much, 130 kPa. Okay, just do this calculation. We will get entropy value as minus 0.04697. Unit will be kilojoule per kg into Kelvin, right? This is what change in entropy of universe, or this will be equals to S generation. Right now you can see, if the air is flowing from left to right, from 1 to 2, its entropy generation is coming as negative, right? So this is not feasible. So as we have discussed for thermodynamic first law, what it defines, thermodynamic second law, it defines feasibility of a process, it defines irreversibility present in the process, it defines directionality of the process. Okay, so here 1 से 2 की तरफ फ्लो होगा क्या, नहीं, 1 से 2 की तरफ फ्लो नहीं होगा. क्यों नहीं होगा, क्योंकि एस जनरेशन वैल्यू इज़ नेगेटिव. ओके, तब कैसा होगा, एस जनरेशन की वैल्यू जिस तरफ पॉजिटिव है उस तरफ फ्लो होगा. तो पॉजिटिव किस तरफ होगा यार, आई थिंक ये क्लियर है, 2 to 1 की तरफ S generation will be positive, so flow will be from 2 to 1, right? So you can give on comment in your exam that since S generation is less than 0, so the feasibility of this process is not possible, so the process is not feasible from if it is moving from 1 to 2. Since S generation will be positive for 2 to 1, so this direction will be feasible direction. Okay, so this is for question number 2. Now let's move question number 5. So okay, so it is given the calculate the change in entropy of 1 kg of air expanding polytropically in a cylinder from 6.3 bar and 550 to okay. पहले इस प्रोसेस को अपन पीवी डायग्राम पे, पीवी कर्व पे बनाते हैं, कैसे बनेगा पॉलीट्रॉपिक प्रोसेस का. सो फर्स्ट कैलकुलेट द चेंज इन एंट्रोपी ऑफ एक्सपेंशन हो रहा है यहाँ पे. ओके, polytropic process, it will be similar to adiabatic process. Adiabatic process, it travels between two isotherms. Okay, so this will be what, adiabatic process. This will be from 1 to 2. Okay, now let's try to write what physical quantities are given here. So it is what, mass is 1 kg, and this initial pressure, this is P1, this is P2, mass of 1 kg of air expanding polytropically, expansion हो रहा है यहाँ से. So I hope you can see that volume is increasing. That's why it is expansion is taking place. So you can just draw it nicely. This will be V1, this will be V2. So here volume is increasing when the mass of air comes from 1 to 2. Okay, air expanding polytropically in a cylinder from pressure P1 is 6.3 bar and T1 is 550 degrees Celsius to P2 is 1.05 bar and index of expansion N is 1.3. Okay, fine. So these things are given and it is asking to calculate the change in entropy. Now what should be the approach? हमें कौन सा फार्मूला लगाना चाहिए यार यहाँ पे? Now I hope this is clear कि यहाँ पे P1 और P2 की वैल्यू दे रखी है. I hope दिमाग में सीधे ये स्ट्राइक करेगा TDS equals to DH minus VDP because pressure is varying here. Okay, so if we write this relation, what we will get? So what we will get here, we get I am just directly writing the formula. This will be MCP ln T2 by T1 minus MR ln P2 by P1. ओके तो यहाँ पे अपन को P2 पता है, P1 पता है, T1 पता है, राइट. T1 पता है. क्या मुझे T2 पता है? क्या T2 नहीं पता है? अच्छा, T2 कैसे निकालेंगे? सो वी हैव टू थिंक दैट हाउ वी कैन कैलकुलेट T2. दिस वी हैव टू थिंक हाउ वी कैन कैलकुलेट T2. अच्छा, it is saying that this air is expanding polytropically. अच्छा, जब polytropically होता है तो कैसे होता है यार? कौन सी इक्वेशन फॉलो करता है ये प्रोसेस? दिस प्रोसेस विल फॉलो दिस रिलेशन. सो व्हाट वी कैन राइट P1 V1 की पावर n इक्वल्स टू P2 V2 की पावर n. Okay, now I hope so here we get just put use PV equals to MRT and put V value here. We will get T2 by T1 equals to P2 by P1 की power n minus 1 upon n. Now if you will put all the values P1 P2 n minus 1 and n, right? So what you will get, now this is the tricky part. Just what you have to do, guys, just take your calculator, okay, and just put these values. Then you will get the T2 as 544 Kelvin. If you are not able to find T2, then just message me or just ask me. Okay, so just in your calculator you put all the values. So here in your calculator you will get some function x की power, that rectangle cube will be there. So you just put the n minus 1 upon n values there. Take n as a 1.3. So we will get T2 as 544. So we will get T2 as 544. And what is the value for CP? CP we know for air we take 1.005 Okay, and here M is taken as 1, Cp will be how much? 1.005 kilojoule per kg, Kelvin. Okay, and this R value will be 0 0.287, right? So this will be 0.287 is in kilojoule per kg Kelvin. Okay, so now put all the values inside this. And you will get the change in entropy, that is S2 minus S1 will be equals to 0.0979 kilojoule per Kelvin. Okay, so this is entropy, this is not a specific entropy, so you can see per kg is missing here, so this is what complete entropy. So guys, here M value is 1, that's why specific entropy and entropy change both are same. Okay, so this is for question number 5. Now let's move another question. So question number 6. Okay, so here it is given 0.05 meter cube of carbon dioxide contained in a cylinder behind a piston is initially 1.1 bar and 20 degrees Celsius. Okay, so now let's write. So here it is giving V1 is 0.05 meter cube of CO2, and pressure is P1 is 1.1 bar and T1 is 20 degrees Celsius. The gas is compressed isothermally and reversibly, okay, until the pressure is P2 is 4.5 bar. Calculate the change in entropy of CO2 in joule per Kelvin. Now let's try to draw this curve on PV. So what is happening here? The gas is compressed isothermally. Okay, so what will be happen? So this is compression. Okay, and this is isothermal curve, that is PV equals to constant. So this is what V1, this is what V2. Okay, now it is saying that calculate the change in entropy. So okay, now this is for temperature is constant through this curve, so T1 will be equals to T2, and you can see here that we have P1 and P2 already given. Okay, P1 and P2 we have already given here, right? So now let's see. Okay, and here we have what carbon dioxide as a gas. In a previous question we have air as an ideal gas, but in this case we have CO2 as an ideal gas. So in case of CO2, what is the molecular weight? CO2, carbon is 12, oxygen is 32, so it will be 44. Now if I calculate the characteristic gas constant for this CO2, this will be R bar upon M, so this will be 8.314 upon 44. So just do this, we will get 0.189 kilojoule per kg Kelvin, or we will get something like this. And now let's calculate the initial mass of this gas. So we will use P1 V1 equals to mRT1. Okay, so from here we will get a small m value as P1 V1 upon RT1. So from here, now do this all the calculation, right? So this will be what 1.1 bar. 1 bar equals to 100 kilopascal into V1 is 0.05 meter cube. So the funda is keep pressure in kilopascal and volume in meter cube. ओके, सो यहाँ से जो भी निकल के आएगा वो किलो जूल में निकल के आएगा. आर की वैल्यू कितनी है 0.189, इट इज़ इन किलो जूल. ओके, एंड T1 इज़ हाउ मच 20 डिग्री सेल्सियस, देन इट विल बी 293. just solve this, we will get 0.1 kg. We will get this as a 0.1 kg. Okay, now just do the calculation. We know that change in entropy, that is S2 minus S1, is how much here m. This is for so we will apply which equation? TdS equals to dH minus VdP. Okay, because here pressure is constant. Now you can see we will get m Cp of CO2 into ln T2 upon T1 minus mR ln P2 by P1. Okay, so the process is isothermal. To T1 or T2 की value T2 by T1 will be 1 and ln 1 will be what 0. And we will this relation put m value as 0.1, r value as 0.189 and ln P2 by P1 is 4.5 upon 1.1. We will get how much? Keep it minus here. We will get minus 260.6 joule per Kelvin. Joule per Kelvin, this will be in Kelvin. Joule per Kelvin, this will be what? Change in entropy. So this is the final answer. So this is question number 6. Let's move to next question number 6, question number 7. Okay, so we will discuss this question in next video, in next lecture. This is very important question for your exam, for your end semester exam. Okay, so this is all for today.